Welcome to Education PNG YouTube channel. Today we solve questions 2, 3, and 4 of PNG Advanced Mathematics questions that appeared in the National Examinations of 2022. Before we go on, please help us to grow this channel. Hit the like and subscribe buttons. Let us begin. Question 2. Which of these rules demonstrates the commutative property if 0, A, B, and C are real numbers? We have 4 options. A. The associative property. B. A plus B equals B plus A. C. The distributive property. D. The identity property. Step 1. Let's define the commutative property. The commutative property states that the order of operands can be changed without affecting the result. For example, A plus B equals B plus A. The key word here is order. Operands swap places, nothing else changes. Step 2. Analyzing option A, open bracket A plus B close bracket plus C equals A plus open bracket B plus C close bracket. This is the associative property. The grouping of parentheses changes, not the order of A, B, and C. The sequence stays the same. So A is incorrect. Step 3. Analyzing option B, A plus B equals B plus A. This is the commutative property. The operands A and B have swapped positions, the order has changed, but the result is identical. This matches the definition perfectly. Step 4. Let's quickly check C and D. Option C, A times open bracket B plus C close bracket equals AB plus AC. This is the distributive property, multiplication distributed over addition. Option D, A plus 0 equals 0 plus A equals A. This shows that 0 is the additive identity. The swap here is incidental, not the main property. Step 5. Final answer for question 2. The correct answer is B, A plus B equals B plus A. This is the only option where the order of operands changes while the operation stays the same. This is the precise definition of the commutative property of addition. Question 3. If 1 square foot equals 0.0929 square meters, what is 1 cubic foot equal to in cubic meters? The options are A. 0.0000283, B. 0.0000304, C. 0.0283, D. 0.3048. Step 1. Understanding the dimensions. We know that 1 square foot equals 0.0929 square meters. We need to find 1 cubic foot. The key insight is that 1 cubic foot equals 1 foot times 1 foot times 1 foot, which is 1 foot cubed. Since 1 square foot equals 1 foot squared, we can find 1 foot first, then cube it. Step 2. Finding the linear conversion. If 1 square foot equals 0.0929 square meters, then 1 foot squared equals 0.0929 meters squared. Taking the square root of both sides, 1 foot equals the square root of 0.0929 meters, which equals 0.3048 meters. This is the standard feet to meters conversion factor. Step 3. Calculating the cubic conversion. 1 cubic foot equals 1 foot cubed, which equals 0.3048 meters cubed. So we calculate 0.3048 times 0.3048 times 0.3048, which equals approximately 0.028368 meters cubed. Rounded to 4 significant figures, that's 0.0283 cubic meters. Step 4. Alternative verification. We can also compute this directly using the given area conversion. 1 cubic foot equals 1 square foot times 1 foot, which equals 0.0929 square meters times 0.3048 meters. This also gives 0.0283 cubic meters. Both methods confirm the same result. Step 5. Final answer for question 3. 1 cubic foot equals 0.0283 cubic meters. The correct answer is C. Option C is the only value in the correct order of magnitude for cubic meters. Options A and B are far too small, and option D is the linear conversion, not cubic. Question 4. Use the laws of logarithm to express log base of x plus log base of y minus log base of z as a single logarithm. The options are A. Log base of open bracket x plus y minus z close bracket. B. Log base of open bracket x plus y close bracket minus log base of z. C. Log base of x y z. D. Log base of x y over z. Step 1. Applying the product rule. The product rule states that the sum of two logs with the same base equals the log of the product. In symbols, log base of m plus log base of n equals log base of m times n. Applying this to the first two terms, log base of x plus log base of y equals log base of xy. Step 2. Applying the quotient rule. The quotient rule states that the difference of two logs with the same base equals the log of the quotient. In symbols, log base of m minus log base of n equals log base of m over n. Now we have log base of x y minus log base of z. Applying the quotient rule, this equals log base of x y over z. Step 3. Why the other options are wrong. Option A, log base of open bracket x plus y minus z close bracket. Logs do not distribute over addition or subtraction. This is a common mistake. Option B, log base of open bracket x plus y close bracket minus log base of z. This is not a single logarithm, it still has two log terms. Option C, log base of xyz. This incorrectly treats the subtraction as multiplication. The minus sign should become division, not multiplication. Step 4. Complete working. Starting with log base of x plus log base of y minus log base of z. First, apply the product rule to the first two terms. This becomes log base of x y minus log base of z. Then apply the quotient rule. This equals log base of x y over z. We have now expressed the entire expression as a single logarithm. Step 5. Final answer for question 4. The correct answer is D, log base of x y over z. Using the product rule, addition becomes multiplication. Then using the quotient rule, subtraction becomes division. This combines all three logarithmic terms into one single expression. Summary of all answers. Question 2, answer B, the commutative property, a plus b equals b plus a. Question 3, answer C, 1 cubic foot equals 0.0283 cubic meters. Question 4, answer D, log base of x y over z. All questions solved.